Hello everyone, my name is Vimal Raj. I'm a lecturer from James Polytechnic College from Department Mechanical Engineering. So today we're going to see the unit number 2, ferrous metal and alloys. So this is according to the SPT syllabus from the subject Mechanical Engineering Material 1625304. So it's a continuation part from the previous video. Today we're going to see about the characteristics and application of ferrous metal part 2. So the content that we're going to look forward is characteristics and application of ferrous metal, malleable cast iron and malted cast iron. So malleable cast iron. So malleable cast iron is essentially white cast iron which has been modified by heat treatment. So it is formed when white cast iron is heated to around 920 degrees Celsius and then left to cool very slowly. Basically this malleable cast iron is an essential white cast iron, so which has been modified for the heat treatment process. So it is formed when the white cast iron is heated to around 920 degrees Celsius. So basically this malleable cast iron can be made when this white cast iron is heated to 920 degrees Celsius. So when it is heated to 920 degrees Celsius and it's been left cool, once after the heating has been done, it has been left for cooling process. So once it becomes cool and comes back cools very slowly, that is called the malleable cast iron. Composition of malleable cast irons are, so it obtained by giving a long time annealing to cast iron. So let me tell you what is about annealing. Basically annealing is nothing but wherein which once the metal is heated and allowed it to cool slowly, so in order to remove the internal stress and toughness, so that is called the annealing. So it is obtained by giving a long time annealing to cast iron. To get the high cast iron, steel scraps 10% to 40% may be added to lower the total carbon contents. So the procedure of obtaining malleable cast iron is as follows. The white cast iron casting along with silica is packed in a steel pot in heated muffle oven or continuous type thermal skin. So the temperature is maintained at 870 degrees Celsius for about 60 hours and casting is cooled slowly in the furnace. Iron carbide dissociates at Fe3CFe3 plus C and thus reduced to malleable cast iron. So this is the step this is the step for making the cast iron basically. So this is the composition of cast iron, how the process is taking place in order to make the cast iron. So next one is the property of a malleable cast iron. So these are the following properties of malleable cast iron. First one, hardness, material resistance to abrasion and indentation. So basically the hardness of the material resistance. So basically these malleable cast iron have a hardness which is highly unbreakable, but it is breakable. I will not say that it is not breakable, but it is breakable, but it has a hardness wherein which it has a resistance to the abrasion and indentation. I will tell you what is abrasion. Basically abrasion is nothing but the process of scraping or wearing something away. So that is the abrasion, and abrasion is nothing but a hollow space, something like a small hole, it's like a hollow in structure. This is called the indentation. Basically, these malleable cast irons are say white in color, and the structure has been metastable carbide in a paleolithic matrix. Though an annealing heat treatment is happening, so I was explaining what is annealing. So the brittle structure as fast gas is transformed into a malleable form. So that is the uh, thing. And next, the property that we're going to discuss is toughness, material's ability to absorb energy. So basically, uh, it is having a toughness wherein which it can easily absorb the energy. So when some impact is falling on this particular malleable casting, it can absorb that impact's force. So it is having a good tensile strength and ductility. So basically these things have been used because they use this malleable casting for this electrical fitting equipments, hand tools, pipe fittings, washers, brackets, etc. So they use this malleable cast iron because it can absorb this energy because it have a good toughness. Next one is the ductility, material ability to deform without fracture. So ductility, we all know that ability to deform without any fracture. That means it can be changed to any a shape in which without any breaking. That means if suppose we want to make it as a pipe, we can make it without breaking the actual material. So breakage is something very important. If suppose any breakage happens in the particular material, what happens is the durability will be going up, because once the material starts to break, you can see the cracks will be there, some fractures will be happening. So once a crack happens is the tensile strength will be less. So when some external pressure, external force has been given, automatically what happens is this will tend to break. So once if it tends to break means there is no use, right? So basically uh, the usefulness, the application is very important for all these materials. Without a application, if there is a zero application with a particular material, then what's the use? See, everyone wants something for their use, right? So uh, if we purchase anything, we need at least yeah, for example, a mobile phone we purchase, at least we want that mobile phone to stay with us for a year, about 2 years. We don't want it for a week, right? Nobody would go and buy a mobile phone only for a week. So it could be really crazy, right? So the ductility of material is very important because it can deform to any shape without any fracture. So next one is the elasticity, materials ability to return to its original dimension after it has been. So it has an elastic property wherein which once you stretch it, it can return back to its original dimension after it has been stretched. So that is also one of the good thing. Next one is the uses of malleable castings. Following are the basic use of malleable casting. So it is used in machine construction. So basically they use this malleable cast iron for the construction of the machines. For example, when you go to manufacturing industries, you would see so much of machines, like a big machines, giant machines will be there. So basically they use this malleable cast iron to make those kind of machine parts. It is also used in the transport industries, like railways and the roadways. They all use this malleable cast iron for their transport. So it is used in heating, cooling, and safety systems. So basically, they use in other systems also. Basically, they can be used in even in the small minute parts like in computers also they can use. Basically, it is used in heating, cooling and safety systems. So they can use this cast iron even in the safety systems. Safety systems could be like the pipe fittings, the electrical fittings, those kind of things could be safety systems, because the pipe and all is very important, because some safety lines will be going on the pipe. So these pipes tend to protect those wires, because anything can happen at any point of time, right? So these wires are very important. So the safety system, they use this malleable cast iron, wherein which it can protect this wire from the uh, impact of any external source. And it is also used in the gas industry. So as I was telling, that it is used for this pipe fitting, and also even the gas and foreign countries and all, the government used to send the gas through the pipes. So they will not put in the cylinder. So basically they will be giving it through the pipe. So they use this malleable casting pipes. And it is also useful in this fence fitting. The fence, everywhere when you go, some big beach houses, they will have a fence, right? I mean a iron fence. So they use this malleable cast iron in the iron fish, I mean like the fencing. So before the widespread use of malleable iron in everyday items, heavy duty bench wires were made from the cast steel. The use of cast steel has rapidly declined in most applications due to its poor castability, and hence high quality cast wires as opposed to forged ones, among other tools. And machine elements are now almost exclusively made with the malleable irons. But we have come to the conclusion for the malleable casting. Now the next topic that we're going to discuss is the malted cast iron. So basically this molded cast iron is nothing but the cast iron or a pig iron that is intermediate between white cast iron and the grey cast iron. So basically it would be in the center, in which white cast iron will be there as well as grey cast iron. So it will be intermediate with both the white and the grey, and shows a malted surface on fracture is known as the malted cast iron. So the iron, which consists of a mixture of a variable proportion of grey cast iron and white cast iron, such as material as malted fracture. Basically these materials will have this fractures and shows a malted surface. So that is called as the malted cast iron. So basically it is a cast iron or a pig iron that is intermediately between a grey as well as the white cast iron. So that is called the malted cast iron. The composition of malted cast irons are this is the combined carbon of 1.75% and the graphite is 1.75%, iron is 93.5%. The remainder are impurities. So basically the composition is will be like this. So it has been combined with 1.75% of carbon and 1.75% of graphite, and 93.5% would be iron. So basically totally how much is coming is 3.50. So 93 plus 3.5 would be going to 97%. The remaining 3% would be the impurities. That means some dust, some unwanted things which is not meant to be there, because everything should have some impurities, because a pure thing might have a chance of breaking, but impurities would be helpful. The properties of malted cast irons: mixture of the two states, grey cast iron and white cast iron. So basically the two states will be the grey cast iron as well as white cast iron. These two cast irons will be mixed. So both these irons will be mixed in a proper proportion, wherein which The strength and hardness varies according to the ratio of the free carbon to combined carbon. So basically the strength and hardness varies differently in this molded cast iron, because if the carbon is combined, the strength would be different. If the carbon is free, the strength would be totally different. So there are so many differences. If you're tying a rope, a single rope, and tying too much of ropes, that is tying a 10 rope and tying a single rope has a different, right? So which one will be having more power, more strength and durability would be 10 ropes. So it is very hard to break the 10 ropes, wherein which it is very easy to cut the single rope. That is how it works actually. The strength and hardness varies according to the ratio of the free carbon to combined carbon, and it has a less tendency to rust than grey cast iron variety. So it has a less tendency to rust. That means rusting is very minimal in this molded cast iron, because it's a combination, right? So grey cast iron will be rusting very soon, I would say, but wherein which this molded cast iron has a tendency to rust very late, and the fluidity is good. What do you mean by fluidity? Basically, the fluidity is nothing but the ability of a substance to float. See, that's the reason they use this molded cast iron in the ships and all. So they can use this molded cast iron in ships because the ability of the material to float, because it has this property wherein it can float. So without any problem, it can be floated. So that is the one of the good properties, I would say, and it's very hard and brittle. So the property of this molded cast iron is it is very hard and it is brittle. That means it can be easily it can be breakable. It is a breakable thing, and it is very hard actually. So the strength would be more and the toughness would be more, because the property of this molded cast iron is having a hard, so it is having a tensile strength would be more, and the brittleness also is there. So this is the example I want to show. So basically these are the usage when it's the only use of molded cast iron is for the manufacture of manual covers. They use this manual cover. So this is a manual cover that is available even in the drainage systems and all. So many people would have seen this drainage cover. Basically they use this material for doing those things, for doing those purposes. For making the manual covers, they use this molded cast iron. So they use for this purpose. And pipes also they use. So making pipes and all. Making pipes also they can use with this molded cast iron. Then is the white cast iron. So white cast iron is a type of a carbon iron alloy that contains carbon content greater than 2% in the form of cementite. So when fractured, it exhibits a silver-like white fractures. So these are the white fractures that you can see. White cast iron is something with a type of carbon iron alloy that contains carbon content greater than 2%. So the carbon content is greater than 2%. So it tend to become a steel. So white cast iron has a high compressive strength and wear resistance. So basically this cast iron has high compressive, that means it can be compressed easily, and high wear resistance. So these are the following combinations following are the elements present in the composition of white cast iron, that is iron 94%, graphite 0.5%, and combined carbon with 3.5%. So, and that the remainder are the impurities. Properties of white cast iron. So the following are the properties of white cast iron: hard, brittle, and cannot be machined. So basically it's very hard and it cannot be machined. So called because the carbon is mostly in a combined form, because the carbon is, it's not a separate carbon, so it's a combination of a carbon. The combined carbon is used, and high resistance of wear there, so it is highly resistant here. Tensile strength is good, so basically durability is more good. Obtained by rapid cooling of metals, so basically it has been obtained by a rapid cooling of metals. So due to its poor fluidity, it does not fill the mold freely. So basically the fluidity is very white cast iron. Use of white cast irons. The use of white cast irons are below. Used to parts subject to excessive wear, example in rim of the car wheels. So basically they use this white cast iron in the car rims. So you could see the car rims and all that will be like white in color. They use this material. So railway brake blocks used for inferior casting. It's not rust so much as the grey variety. Used for making malleable castings also. With that, we have come to the conclusion. So we have discussed about the various types of engineering materials, studied of the properties of the material, and these are the reference books you can go through. We have come to the conclusion video. Thank you for watching this video, guys.